Welcome to Radar System course. We start with the discussion on the navigational aid. So we have seen earlier a instrument landing system that will help to land aircraft properly even in adverse weather conditions. And for this ILS, that instrument landing system, there are the two markers that is used, that is outer marker and a inner marker that we have used to identify or to find out the what is the position of the aircraft from the runway there. So inner marker, outer marker, as well as the middle markers are there, and that marker beacons that will provide you the information about the what will be the height there. Means that is just like we can say that a marker is useful for the altitude checking. So what will be the altitude of your radar or a system that target, that is to be, that information is to be obtained through the a marker there. So if you see the ILS system, it has a antenna that will provide you the horizontal information as well as the vertical information. And we consider that a two approaches here. One is to be used as a glide slope and another is about a localizer. And that ILS, if you see, it has a high intensity approach lights here. Then next we have seen a navigational aid, that is a distance measuring equipment, a DME. Okay, so this one is about instrumental landing system. This one is a distance measurement equipment. Now in this distance measurement equipment, we just find out the what is the distance from the a ground system to the aircraft there. And this system is useful for the measuring the range, and that will be useful for the 100 numbers of a aircraft. It is just like a ground based navigation system developed for the aircraft one. So it is mostly used on the airport to measure the what will be the a distance there from the airport terminal or airport position to the aircraft there. Okay, so this one from the ground signal is to be sent to the aircraft, and then aircraft receive the signal from the ground system, then convert it, process it, and resend that signal back to the ground system. And then time taken by the particular signal for the processing, and from this we can find out a range here. So generally we say that the range here, it is in a nautical miles, equal to what will be the total time required. Okay, that total time, everything is in a microsecond minus a time delay, all is in a microsecond, divided by 12.36. So through this we can get the what will be the range of the aircraft from the a ground system there. Okay, so now these are the two systems we have seen. Mostly this DME is useful for the navigational aid for aircraft. It is useful for the distance measuring between the aircraft and a ground system there. Means just we can say that it is a distance measuring equipment, or you can say that distance measuring a device there. And this DME provide a continuous navigation for a 100 aircraft. So operating frequency for this DME is about a 960 megahertz. We can say that is about a frequency to 1210 megahertz. That is about a operating frequency. and generally a power watt output is about a 1 kilowatt of a peak power output, and a maximum transmission rate, that is a 2800 pp per second. So we can say that this system is useful for the aircraft navigation in any weather condition. Now these are the two systems: IRS, instrument landing system, and a distance measuring equipment. These are the two systems we have seen earlier. Now we continue to understand that another system, that is called as a VOR. Okay. So next navigational system that we will learn here, that is called as a VOR. VOR, VOR stands for very high omnidirectional omnidirectional range. That's V. Okay. So very high O and range, VOR. Okay. So now we have we have mentioned earlier that all the navigational aids useful for the determining the range of a aircraft or to provide the path to the aircraft for the runway there. So how to land the aircraft, and that same here in a very high omnidirectional range. So in which it will provide a path or provide a information regarding a landing system. So here we are present on a ground system. Okay, we have a transmitter and receiver on the ground. So we can say that on a ground we have the ground equipment, that is VOR transmitter on a ground, and in aircraft it has a VOR receiver. Now if you consider here, so that range of this VOR operating in a VHF band, that is from the 108 megahertz to 118 megahertz. It's just like providing a signal. We can say that it can transmit the signal to the aircraft and then receive the signal from the aircraft. So distance between this transmitter and a receiver, so it is about a 150 nautical miles to the 200 nautical miles. That will be the a distance altitude from the ground system to the aircraft. So it provides a indication of a aircraft within the particular region, and then it will track a aircraft from the station. Okay, so it will use a omnidirectional antenna. So one antenna is a fixed one and another antenna is a rotating one. So it provides a two signals. One is a fixed signal and it is and another signal is about a variable one. So mostly we can say that it it operates using a two signals, and based on this two signals, what will be the phase comparison of these two signals? So that will useful to provide the tracking information of the aircraft there. So what will be the range, or we can say that what will be the bearing of the aircraft to this VOR location, that will be determined by this VOR navigational aid. Now there are the two types of a VOR. One is called as a conventional VOR and another is called as a Doppler VOR. So if you consider that a CVOR, conventional VOR, okay, so in that case it's just like a common one, but in the case of a a Doppler VOR, it will more accurate than this a conventional VOR. And this that's why a VOR is not used. So Doppler VOR is mostly used, and this Doppler VOR, it is used on a principle of a phase comparison of a two signal. So generally, how it works? So if you see that on a aircraft, there will be a ground antenna system. So we have a antenna system, and then a aircraft is moving toward the aircraft moving toward the a runway or a on air this one, we can say that toward the airport. So we can provide from this ground equipment one transmitting signal to the aircraft, then transmitting then signal view that VOR receive the signal. Okay, so likewise, so we can say that a signal will be transmitted as well as will be the signal will be received. So we have the a ground equipment, we can send the signal to the transmitter, then it will be received at this VOR. So what are the components at a receiver? What are the components at a transmitter here? And then generally we can say that this one is about a bearing angle. So what will be the bearing of a aircraft? So mostly if you consider this a landing system, so we need to consider how much will be the degree of a bearing. So for that purpose we need to find out uh, a south and north pole. So we can just consider from the earth, and according to that we will find out what will be the degree of a rotation. So means what will be the altitude. Okay, so what will be the position of a aircraft that can be obtained through this VOR. So signal will be sent. We can say that we need to find out what will be the phase difference between the a signal. So means here we have the antenna. A continuous signal is to be sent, and another signal is about a narrowband signal, and that signal is rotated by this a phase array antenna. So we have the antenna. So that antenna is rotating. So mostly if you see, so it just looks like a circle. So we have the antenna. So likewise, so it will, we can say that this type of antenna we have, and it will be rotating. So from the position, what will be the north and south and now north here, or we can say that what will be the east west position. So according to that we can find out what will be the position of the aircraft. So from this, if you see here, so this one is about the direction of the aircraft. Here is your aircraft. So signal will be sent by the aircraft at this particular position. So we can find out what will be the altitude. So mostly we can consider your aircraft is moving, and then a signal will be received at this VOR. So from this whatever the aircraft, so according to that we are able to track the what is the position of the aircraft there. So if we consider on the ground system there is a another VOR. So from this we can find out at what location, so the position of the aircraft. So VR ground station transmits a signal, and then it assigns some particular frequency, and then it will transmit a signal. One is about a reference signal, another is about a variable signal. So one is about a fixed signal. So we can say that earlier it will transmit a fixed signal. Okay, so we can consider the VOR now. So we can say that there are two signals. One is about a reference signal. So that reference signal is a constant in all directions. That's why we can say that a continuous omnidirectional signal, and another signal we can say that a narrow beam signal. Okay, so it varies with a phase. So that's why we can say that a variable phase signal These are the two signals will be transmitted by this a VOR. So this one is a fixed. So we can say that a continuous omnidirectional signal that will be constant in all the directions. So that's why it's called as omnidirectional. Omnidirectional means what? It transmits the signal in all the directions. Okay, but we say that this is in a one plane. Okay, so we can say that we have a transmission of the signal in all the directions. That's why we can say that a omnidirectional one. Okay, so in a one plane. Okay, so then these are the two signals. So then, so what will be the phase difference between the reference signal and this variable signal? And that will provide you the position of the aircraft. So if you consider that, what will be the altitude? So, what will be the phase variation with respect to this one? So according to that, we can find out a position of a signal. So for example, supposed to be we can say that a VOR is here, and then we can find out a position of the signal. So this one is about a vertical one. Okay, so according to that, whether it will be toward the north, so in that case it will be toward the north. We can find out the angle here. So if it is a toward this one, we can find out this angle likewise. So likewise we can find out the a position. So okay, so at what will be the difference here? So generally the difference is to be obtained with respect to a north and a south, that is about at a magnetic pole here. And then, so from the north, what will be the position of the target, and from the south, what will be the position of the target there? So according to that, we can find out the this particular phase difference, and then that phase difference is useful for identifying the what will be the altitude of a aircraft. So there are the two type, we can say that it generally we say in terms of a two altitudes, we can say that high altitude and a low altitude VOR. So in that case, both are using the same frequency, but except only because variation, because range of the frequency is same, only there is a small variation in the frequency. Generally we say that it will be operating from this 108 to 118 here. So in between these particular frequencies, two signals are supposed to be considered. So that's why we can say that for a high frequency, high altitude VOR, we consider that 112 to 117 means 118 here, and that range for the high altitude VOR is about a 200 nautical miles. Then a low altitude, so that range is about a up to a 400 nautical miles. So what are the various VOR ground equipment? So VOR ground equipment consists of a crystal oscillator, because we can say that a signal is to be transmitted. So this one is a crystal oscillator. Then a frequency multiplier. Okay. Then next is about a power amplifier. This one is about a power amplifier. And then we can say that a modulation eliminator. Modulation eliminator. Okay, so then we have audio amplifier, because a signal is to be sent. So power amplifier. Then a modulator. Then we have a signal is to be transmitted from the power amplifier. So that's why we can say that the output of a power amplifier will goes to the antenna. This one is about antenna. So antenna is a rotating one, so that's why we need use a rotary shaft to the antenna. You can say that rotary shaft. Okay, this one is about a rotary shaft to the antenna, and then a we can say that it has a rotated wheel. Okay, so that antenna will be a rotated one, and how this antenna is to be rotated to the a servo to the servo motor. Okay, so this through this antenna is going to be rotated, and then how much is the rotation is to be takes place, that will be given to the input to the a power amplifier here, and then rotary shaft that will be input to the given to the a modulator, and modulator output is to be given to the a power amplifier. So bearing of aircraft is just like found by comparing the phase of a reference signal and a variable signal, because we have said that earlier what will be the bearing there, and then a ground equipment, it consists of, we have a VOR ground equipment, it consists of a audio amplifier, a crystal oscillator, frequency multiplier, modulator, modulation eliminator, and a phase array antenna there. Then voice input signal that will be amplified, okay, so through this audio amplifier there, and then that will be given, okay, so this one is about a voice signal that will be amplified by the audio amplifier, and that will be given to the a power amplifier. Then a signal, another signal that will be from the crystal oscillator, that will be given to the frequency multiplier to the a power amplifier here, and then output of this power amplifier here, audio amplifier, that will be given to the modulator here, and then output of a modulator, okay, so you can say that one input from here, one input here, and then output of this modulator is given to the a power amplifier, okay, with the same signal frequency of this frequency multiplier. Then output of this power amplifier is fed to the modulation eliminator here, and then that will be given to the antenna there. Okay, so we can say that one output to the modulation eliminator and one output to the antenna here. Okay, so likewise. Then this one is about a VOR ground equipment. Okay, so then another case we can consider that we have the a VOR ground equipment, and then we need to know about, so what will be the uh, position of this antenna here. Okay, so at a receiver, we can say that at a aircraft. We just remember that these are the signal to be given to power amplifier, then to the antenna, then that audio signal is to be transmitted here. Okay, so then at a receiver, so we have the signal will be received by the antenna. This one we can say that we have the antenna here, then that antenna signal will be propagating to the given to the RF stage. This one is about the RF stage at a receiver, this VOR receiver in the aircraft, then to the IF stage, then a audio amplifier, and then that will be given to the out to the speaker. Okay, so you can say that a output here, then a IF stage output, there is a switch, one is about, consider that a localizer, we can say that a filter. Okay, just like we can consider there is a one particular filter, and then one is to be used for the range. Okay, then that will be displayed on the display device. Okay, so this one is about a display. So antenna to the RF stage. So signal whatever the ground equipment of a VOR that will transmit the signal. Okay, VR ground equipment will start transmit the signal. Then the signal will be reached to the RF stage. Okay, so this all these blocks are present in a aircraft. So so we can, that's why we can say that we have the RF stage there, and then we have the IF stage. So RF stage consists of a mixers and all. So it's just like aircraft receiver that are VOR receiver in the aircraft, that is called as a super heterodyne type. And then it has a omnidirectional antenna, then a RF stage, then IF stage. Okay, so then we have a audio amplifier there. Then there is a change switch here we can consider, and that change switch is useful to switching the location as well as the range, and that will be displayed on the display devices. And here is one speaker regarding the audio signal is to be indicate audio signal is to be okay observed on the speaker there. So on a display device, what will be the range, okay, and a location that will be indicated on the display there. So the transmitting frequency range, that is about a VR ground equipment is about 108 to 118 here. So similarly, the same frequency range is to be used at a VR receiver, and then whatever the signal to be received by this VR equipment, okay, so from the ground station, because there are more, not only a single VR ground equipment, there will be the more ground equipment, and aircraft is receiving from the various ground equipment stations. So that's why a receiver frequency range that is to be used here will be the 108 megahertz to 135.9 megahertz. Okay, so we can say that this one is about a frequency range. Okay, that is about a frequency range. And then this particular frequency range, it will cover say 560 allocations, means which we means allocations means signals that will be received, and that signals are separated by a 50 kilohertz. Okay, so we can say that is separation frequency range. So means it will receive the signal. Okay, so we can say that a non-directional signal, and then we can consider that just like we can earlier say that there are the two signal, one is about a reference signal and a phase signal. So similarly at a receiver, so it receives a non-directional signal, rotating directional pattern, and a fixed reference signal there. So we are equipment that will receive the signal there. Then once a signal received, then signal will be demodulated, and then what will be the variation in the phase of that 30 Hz signal and a reference phase input signal, that can be obtained here. And these two signals are separated by the filter. So you can say that there is a low pass filter, and then that particular two signals will provide you the information about the what will be the direction. Direction can be obtained by the comparing the phase of this a variable signal, and then we can find out the what will be the a rotating field with this page reference signal. So to obtain this, what will be the rotating field? We need to observe the what will be the voltage of a given particular signal. So through that we can find out the what will be the rotating field with the whatever the page reference signal. And then phase comparison, just to compare the phase, we use a phase shifting circuit or a phase detection. And because at a transmitter there is a servo motor, so we can consider that what will be the changes in the phase. Okay, so likewise that changes in the phase can be obtained through this receiver. So if you see here a VOR, that will be useful for the identifying a location there. So we can say that a audio and visual indication of a bearing made available through this VOR ground equipment, and this one is used in all the season, but there is a variation in the during day and a night. So that's why we can say that in all the variation in the ionization density, so that's why we can say that if VOR is to be used in all weather conditions. Okay, so whether it will be in a day or whether it will be in a night there. But only the difference is here that uh, we can say that VOR, because on a ground station, so it requires a calibration, and then uh, we can consider that whatever the servo motors and everything used at VOR equipment, so we consider the signals and everything is to be calibrated there. And this VOR is about a range. To obtain the range, it is dependent on the what will be the aircraft signals and all. Okay, so mostly it can be useful for the a large number of aircraft. We can say that 100 number of aircraft and all. So that VOR provides you the what will be the distance there. So mostly if you consider any aircraft in a cockpit, so it receive the a VOR frequency is there, and then that will be observed on the display devices. So we can have the likewise a indicator there, and then it will provide you the position. Okay, and then it has a frequency device, so we can vary this particular frequency and display on the display devices there. Okay, so likewise, so observe that what will be the omnidirectional selector there, or we can say that what will be the frequency sent by this VOR equipment there. Okay, so if you consider this one, so we have a continuing this what bearing information or to obtain the what is the position. Okay, so that's why we need to find out so what will be the two signals to be transmitted. So same navigation system with a advanced version, so we can consider that another navigation system, so that is called as a tactical air navigation system. So it has a VOR. Okay, so that TCAN is again it has a VOR as well as it will useful for the distance measuring issue. So what we have seen earlier, that is about a distance measuring equipment DME. The same thing is present in the another navigation system. So we can consider the next navigation system, that will be a TA CAN. Okay, so this TA CAN means what? So it is about a tactical air navigation system. Tactical air navigation. Okay, so that's why it is called as a TA CAN. So TA CAN, this one is about a TAC A, and this one is about a A. So TAC here, A and N. So tactical air navigation system. And this one, a navigation system, mostly it will be used by the military aircraft. Okay, so even on aircraft, this can be used, but it is very faster one. So it has a one driven element, and it has a most parasitic element, and it will draw a directional pattern of a TA carrier. So it provides you the what will be the distance and a bearing from the ground station. Okay, so we can say that bearing information. Okay, so that's about what is the bearing information from the ground station that will be provided by this TA CAN system. So means we can say that it will be useful for a distance and a bearing information from the a ground system there. So it's just like a VOR TA CAN. It's just similar to the VOR here. Okay, but it will this TA CAN is more accurate as compared to the VOR and ADME, and this one it uses a two frequency principle with one, because we have seen earlier in a VOR it is using a two signal. So similarly it uses a two frequency principle with one is about a 15 hertz signal and another is about a 135 hertz of a signal there, and mostly it operates in the frequency range of what a 960 megahertz. These are the two signals to be propagating 1 to 15 megahertz. If you see that earlier 118 to 1 to 15 is about the VOR receiver. Okay, so 1 to 1. So similarly, this one again TA CAN is again in continuation with a VOR here. Now, what will be the TAR units of how this TA CAN units operate here? Okay, so mostly it is about a military landing air navigation system, and that will provide you the what will be the range information and the bearing of the ground station. Okay, so distance, that is about a range. So from the military aircraft, okay, so what will be the a bearing information? So for example, if you consider that this one is about a aircraft now. Okay, so mostly we can consider that about a aircraft. So we have this one is about a aircraft now, and then what will be the a ground station? So consider the ground station. This one is about a TA CAN ground station. Okay, this one is about a TA CAN ground station. Okay, so now a signal from this ground station, what will be the a slant range? So this one we can consider that the about a slant range. So we can say that from the ground station, this one is about a slant range here, and then through the toward the a magnetic, okay, magnetic bearing of the orbiter here. So that's why we can consider here. Okay. So from this aircraft, this one is about altitude now. Okay, so this one is about altitude, and then from this we can find out is what will be the this one supposed to be a magnetic north now. Okay, so this one is about a magnetic north, and then it will provide you the information regarding what will be the a bearing. This one. So this one is about a bearing from the magnetic north. So just generally in a north and south pole, we use to find out the what will be the bearing information there. Okay, so that's why we can say that a magnetic bearing of the orbiter with respect to the ground station. This one is about a TAC and ground system, TAC and ground system here. So whatever the range and a bearing data that are used to update and increase the accuracy of the navigation of a military aircraft there. Okay, generally you can say that that is called as a flight pages is for what will be the approximately a height in terms of a feet. Okay, so just like a military landing system, so what will be the altitude and all that that is to be updated. Okay, if there is no military landing system is available there, so in that case a TA can is useful to obtain the a range as well as the a bearing one. Okay, so now it will consist of a that TACAN data. So generally we can say that the TACAN data is nothing but a range and what we can say that a bearing information. So this information is useful for obtaining the what will be the position now, okay, or a location there. So mostly if you consider a VOR that is useful for the aircraft, but here a TACAN it means civil aviation purpose, and this TACAN is useful for the military bearing information. Okay. So same how your TACAN transmitter send the signal. So similarly we have a a TACAN system. So that will useful to find out the a range there. So means we can say that a TACAN is operate to obtain the range information of the aircraft there. And then how it find out that what will be the range? Just we have seen earlier that is a DME system, or distance measuring equipment. So in which what will be the time required to travel the signal and a delay. So from this we can find out the range. So similar here, it determines a round trip travel time of the pulse RF signal, and then whatever the echo signals received there. So according to that, it will find out what will be the a range. So mostly it's just like a consider the signal to be transmitted, and then how much is the time taken by this particular signal, and then that signal travel time that will be useful to determine the round trip travel time. Okay, that will be useful to determine the what will be the range here of the aircraft. Okay, so means we can say that what will be the distance here. So in a TACAN, it has a transponder. Okay, so it will transmit the signal, and in a similarly in aircraft again, it has a interrogation pulse that will be transmitted there. Okay, so we can say that we have the airborne equipment or in aircraft interrogation pulse means that particular signal is to be transmitted, and then it here in a TACAR system that pulse whatever the transmitted by this air, aircraft there, so that will be received by this a TACAR system that is present on a ground, and then here it has a transponder. So transponder will receive the signal and then it will modify it and then resend that signal to the aircraft. Okay, so that interrogation pulse received here, and then because transponder is responding, okay, means sending the signal to the aircraft, so according to that, so some delay is there. Okay, transmitting the pulse to the TACON and then pulse back, okay, receive back to the aircraft. So there is a delay. So that is about a round trip time, and that will be useful to obtain the what will be the distance from this military aircraft to the ATACON station there. So just it is used to locate the is useful for the finding the range and as well as the what will be the location of a transmitting beacon, and that will be identifying from this frequency as well as the identification code, And TACON it uses a pulse pair in the operation to increase the average radiated power, and it is used to reduce the interference. Then it has a radio beacon and a radio set in the aircraft, like a beacon signal sent by the aircraft there. And then radio beacon consists of transmitter, receiver, antennas, and a power supply, same that we have seen earlier for the ADME there. And this one is useful to determine the distance for about 100 aircraft simultaneously. Means we can say that a TA can respond to the whatever the signal there, and then according to that it will find out the what will be the a position there. Okay, so it provides a distance and bearing from the ground station, and it provides a better accuracy there. So only a drawback of the system, it does not provide a security features in a TACON system. So that's all about a TACON system. So with this, we stop here. Okay, so we will continue again in the next lecture because we stop here.